Hi, my name's Ryan and welcome to our AWS webinar entitled Journey Through the Cloud. Today we're going to look at disaster recovery and some of the customer examples of how people build disaster recovery infrastructure within AWS. This webinar is the start of a Journey Through the Cloud series of webinars that we'll be giving over the coming weeks. And the idea behind the journey is that we're going to discuss common use cases and stepping stones allow people to get into the AWS cloud, that allow people to learn from customer journeys, the journeys that they've taken, the first steps they've taken into using cloud resources, and to pick up some best practices on how to bootstrap your project in AWS. And today's topic is disaster recovery. So the idea behind disaster recovery in AWS is that fundamentally it allows you to explore using AWS for a non-production use case. That is a use case that is out of band of live production systems. And that gives you a bit of space to choose your success objectives for a cloud project in general. Use it as a learning ground for understanding the dynamics of cloud and how that fits into your business and your technology infrastructure. And you can use it as a useful way to phase systems into live use with relative ease. So you can pick and choose components of an architecture, try them in AWS, see how they perform when you do controlled failovers into AWS, and then bring them into a critical part of your infrastructure and use them as part of live DR. So with that in mind, today's agenda will start with why AWS is a good place for doing disaster recovery systems. We'll look at the services in AWS that can be employed, from storage to compute services. We'll look at some of the architectural patterns that are in use around disaster recovery and more general ideas of business continuity. And then we'll look at a specific customer example, so from ground up, how a customer has used AWS as a fundamental part of its business continuity strategy. And then we'll give you some tips on where to go next. So why AWS for disaster recovery? AWS is used by many companies in a variety of ways. So it's been tested, if you like, in the field by real people using it as part of their DR strategy. So if you look at people like Sogeti, they're using it to do backup and disaster recovery for their Oracle apps estate. Sage benefiting from a DR environment and including things like their testing environment for disaster recovery, reducing overall IT overhead and the availability of systems. BMC Software using it for over 14,000 VMs across their distributed remote sales offices, so they can easily fail over into AWS when they have an issue of any particular location. And Toshiba handling critical medical imaging data and creating a backup for disaster recovery in AWS. So a variety of customers with differing lines of business and interests that are using AWS to manage disaster recovery and increase their overall reliability, availability, and decrease the sort of risk that they'll entailing when they have a DR plan and when they need to enact it. So these customers tell us various things about why AWS has benefited them in this particular use case. And the four I've drawn out here are the main themes that I see across all these use cases. The first of that is reducing costs. So one of the fundamental economic arguments of using AWS is that you can reduce your overall IT budget, and DR is no different. So customers talk to us about slashing disaster recovery budgets by up to 50% by including AWS as a critical part of that plan. You can obviously reduce on-premise infrastructure, and that contributes to the overall reduced costs. So customers talk of speaking around 30% plus of on-premise physical equipment no longer being required. So this could be physical hosts, virtualization hosts that you're managing, storage area networks, and equipment like networking and so on that would go into potentially a second site. Third argument there, leading on nicely, is consolidation of sites. So traditionally you run two data centers, and that if you take AWS as your secondary data center, you can eliminate the need to run a physical second site. And lastly, you can remove aging technologies. Quite often, a key part of a disaster recovery or business continuity plan is the archive of information in long-term storage, such as tape. And with AWS and some of the services that we offer, you can remove those technologies and move on to a more future-proofed cloud-based solution. When you think about disaster recovery and business continuity in general, it's part of a wider set of policies and controls. So disaster recovery there on the right is all about getting your applications and data back after some sort of major event or disaster. But starting on the left, keeping your applications running 24/7 in a high availability configuration is where this all really starts. And in between, it's talking about the backup of your information, so making sure that critical data is safe. And it's not an all or nothing thing. It's not about throwing a big switch one day and turning all your existing assets off and failing over to some new environment. You need to choose what fails over and what does not under varying different conditions. So some things will be more important than others. A classic would be that your internal telephony systems are working fine, but some sort of critical business application isn't. So some things will still be working and others will not. And in that condition, what you're looking to do is to be able to selectively fail over parts of your estate or recover parts of your estate, depending upon their criticality to you and the business that's using them. And 2 points that really drive the science behind disaster recovery are recovery time objectives and recovery point objectives. So how quickly do you need an asset to be recovered, and how fresh the recovery must be for that particular asset? So the balance between an RTO and an RPO is one of the driving influences in deciding the architecture behind a particular disaster recovery strategy. So you might have an application that has a recovery time objective of 15 minutes, and its recovery point objective might be 0 data loss. In which case you're going to drive a hot application deployment between your disaster recovery and your primary site. Other applications might have a recovery time objective of a day. You can take a day to get this application back because you can survive without it for that period of time. And its recovery point objective might be 1 week out old data. This could be a reporting database or a business warehouse or something like that. And if you take RTO and RPO on sort of the spectrum, they drive different technical complexity of a type of solution. So at one end of the spectrum, we have rebuilding when required from an offsite backup. So we could talk about a reporting system and a database, for example, on the spectrum. At the other end, we have running hot with an automatic failover between systems. So this might be your customer-facing transactional web application that you simply can't do without, the front door to your business, the driver of your money-making activities. And in between, you'll have different applications that have different requirements, and they'll sit on a spectrum of technical complexity. So on the left being relatively simple, and on the right being more complex. Fundamental economic model, though, regardless of where you sit on that spectrum, is around the operation of a primary and a secondary site. So using a utility on-demand data center, we're all about taking away the need for you to run a secondary data center. So all the things that come included in the secondary data center, such as networking, firewalling, application licenses you need to run, the operating systems you need to configure and maintain and patch, the servers that need to be installed, storage area networks that need to be kept in synchronization with a primary, and so on. All these things need to be done on a secondary site. And with AWS, at a very basic level, you can operate with simple snapshot storage or backups of information in AWS with everything else turned off until you need it. And that's a starting point for our architectural patterns that we'll come to later. So fundamentally, it's about reducing your secondary site costs by moving them into a utility on-demand data center. So considering AWS as a second or indeed third data center that you have as part of your estate. Now, Companies that operate sophisticated disaster recovery plans are often global in their operations, so it's worth looking at how AWS is distributed around the world. So AWS is a global infrastructure, and that enables you to do quite sophisticated things from a DR perspective. So you might choose to host data in multiple regions, for example, and expand your disaster recovery to handle entire regional problems. So if you're in Asia, you might choose to use our Singapore region and our Japan region, and you might be fault tolerant in that case in your disaster recovery plan around particular natural disasters that may have a higher risk factor than, say, you have in Europe. So leveraging the global infrastructure is a useful aspect of reducing overall risk in a DR plan. And of course, AWS is built to enterprise security standards. So DR, by its nature, is handling the very sensitive data that you probably already have in your internal data centers. And as such, it's useful to draw out some of the certifications so they're consistent on a global basis. So AWS is SOC 1, formerly SAS 70 audited, or ISO 27001 on a global basis. And on both of these audits and certificates, you can go online into our security center and see white papers which discuss all the controls that we operate to ensure that our foundation services are sophisticated in the degree that we control their physical and logical access and security. We're also PCI DSS for the services here, EC2, S3, EBS and so on. So that means if you're a PCI compliant organization, you can build software, you can deploy software and disaster recovery strategies and extend your PCI compliant processes into AWS. And for those in the US, we're FISMA moderate and HIPAA compliant. So we operate sophisticated physical security around these facilities. So the ability for you to store your backups in these facilities will be such that it's at a level that your internal security teams will see it as a natural extension to your existing data centers. So let's look at some of the services that can be employed as part of a DR strategy within AWS. The ones that I've drawn out here today are ones that are commonly used as part of a DR strategy. Starting on the left, we're looking at some of the storage services that we have. So Amazon Simple Storage Service S3 is our object level storage platform with very high durability, 11 lines of durability around objects that are stored. And it's this that forms the backbone of storing things like backups. So when we look at some of our architectural patterns, S3 is a fundamental cornerstone on that strategy. We also provide a service called AWS Import Export, and you should never underestimate the bandwidth of a speeding courier van, because you can ship us physical media and we will attach those to our network and upload those and create those as objects within S3 for you to use. So you can produce a regular stream of physical media and send it to us, and we will store that in the cloud for safekeeping. Likewise, you can pull data back on that basis. So if you have very large data volumes that need to be backed up or archived, import-export is a useful service. We also have Storage Gateway Service, and we'll come on to this a little bit later, where this is effectively an appliance that you can download and install on your on-premise infrastructure that will synchronize a storage area network into Amazon S3, so creating a continuous backup of your data in the cloud. Then moving to the right, we have networking services, where we can connect you directly to the AWS cloud with Direct Connect, creating your own private internet link with guaranteed bandwidth and consistent latency that enables you to extend your existing data center into something like a virtual private cloud, VPC, in AWS, where you can take a private slice of AWS, run your internal systems in AWS, extend your existing networking topologies into AWS, and be confident that it's not publicly accessible. And then we have services like Route 53, our global DNS service that enables you to do sophisticated failover of publicly facing services on a global basis. And when we look at the architectural patterns, we'll also introduce some of the foundation services. So running compute in AWS with the Elastic Compute Cloud, running databases with our relational database service, and managing disks on Elastic Block Storage and their associated snapshots and backups. So at the basic level, AWS storage is ideal for DR. So S3, the simple storage service, and the Elastic Block Store that I've just mentioned are fundamental basic building blocks of any DR strategy in AWS. Simple storage service is a highly scalable object storage, as I mentioned, and you can store objects up to 5 terabytes in size and any number of those objects unlimited in an account. So 5 terabytes could represent a disk image, for example, that you create, and when you store that in AWS S3, we'll store that with 11 nines of durability. So we'll write that multiple times across multiple physical facilities within a region that you choose to store your data in. So it's highly redundant, and therefore it has a very high durability. So your objects you can be safe in the knowledge that your objects are securely saved, and that you don't need to create additional backup or archive copies of the data you've stored in S3. On the right hand side, we have Elastic Block Store. Elastic Block Store is our high performance block storage device. So think of this as a disk drive, and these are disks that you can attach to running instances or compute units within AWS. And these can be up to 1 terabyte in size, and they mount as drives and come with great features around snapshotting and cloning functionalities. So their awesome feature is that you're able to store snapshots in S3 and then reconstitute as many copies of those drives as EBS running volumes as you like and attach them to new instances. And again, use of S3 and the combination of that with snapshots and EBS drive a fundamental recovery strategy in AWS and some of our architectures. So objects in S3, just some statistics which are useful to know. So we have recently surpassed 1 trillion objects in storage in our S3 storage platform. So as I said, that's objects from 1 byte to 5 terabytes in size. And the rate of transactions that we have at peak is 750,000 transactions reading or writing data into S3. So the point of showing you this slide is that we operate S3 at a significantly large scale. And as part of our learnings over operating this service for 6 years, we've understood the dynamics of running a service that's highly durable and highly available. So it's somewhere you can trust to put your data. And one of the things that we manage in there is the entropy of information that you might store in it. So that is, we're continually scanning and detecting the issues and consistency between the copies of your data that we hold across physical locations within an AWS region. And when we detect problems, we automatically correct those problems. So your data is kept consistent across multiple redundant copies, and it's done at an extremely cost-effective price point. So it forms that fundamental building block of a backup strategy in AWS. Bit more detail on the networking options. So when you're considering placing applications in the AWS cloud for purposes of backup or DR, it's useful to understand how you can connect to those applications, particularly if you're discussing maybe internal applications such as Oracle applications or SAP. You might be considering how you're going to create that as a private part or an extension of your existing network. And we provide various services that enable you to do that with ease. So Direct Connect on the left is a dedicated connection between your IT infrastructure and the AWS data centers. And you can you're effectively buying a port on a network that gives you private access to AWS, and you can extend your VLANs, therefore, your network topology, into AWS and share the address space. So your IP addresses that you want to use, you can simply import into AWS. And over Direct Connect, you can use a VPN connection. So we provide a hardware VPN endpoint, which you can connect your VPN endpoints to and create a secure IPsec connection across the Direct Connect. You can also do that across the internet as well. So you can have a dual approach to connecting to AWS, creating fault tolerance indeed in the connection between your data centers and Amazon. And when we look at our customer case study, that forms a key strategy on keeping the connection live between their sites and their secondary cloud-based data center. Lastly, we have virtual private cloud. Mentioned that in terms of extending your address spaces into AWS over Direct Connect. And virtual private cloud is the other side of the coin for that. So this is an ability for you to control at a fundamental level the network topology that's operating in EC2. And it enables you to create a private portion of AWS and choose whether certain applications have route to the internet or not. So this gives you fine-grained control over networking, internet access, NATing, internet gateways, and so on. So there's some of the building blocks in the AWS toolbox that you can use to construct a DR architecture. So what are the DR architectures that customers are using? There are four main patterns that we see. Starting at the left, we have backup and restore. So simple process of keeping and securely managing the backups of information and systems, and then giving you the ability to restore those when required. So remember the spectrum, these sat on the left in terms of low complexity. Then moving to the right, we have Pilot Light, which is an architectural pattern that keeps a certain proportion of your infrastructure alive, so that when you need to invoke DR for a given application, you can simply start turning things on. Through Warm Standby, which moves along that complexity spectrum. So this is where we're running systems in an on state and being synchronized to meet some sort of RTO or RPO objective. And then we have multi-site solution in AWS and on-premise, where you're running in a hot configuration between a physical data center and AWS, and that you're really here for meeting transactional system requirements that have, for example, very, very short recovery time objectives. So today we're going to focus on two of them, and these two really are the starting points of a journey, with Warm Standby and multi-site solutions simply being more complex implementations essentially on top of a Pilot Light. So it's useful to understand backup restore in the first instance, which is what we'll look at now. So backup and restore, so the advantages to starting here is that it's really easy to get started with a backup and restore strategy within AWS. It's a very low technical barrier to entry, and you can focus on incorporating cloud into your DR strategy, not on complex issues related to maybe a hot system deployment, and maybe some of the architectural changes that might come with a particular application that you need to deploy in that way. It's cost effective, so you can achieve very high levels of data durability of backups, because effectively all you're really talking about is the cost of storing snapshots in S3. And you can also move into the realms of removing maybe tape archiving in a physical facility by using the archive features of a product called Glacier, which we'll come on to shortly. So backup and restore pattern, it's all about the preparation process in the first instance, and it's about taking backups of current systems, storing those backups in the cloud in S3, and then moving those backups into archive for long-term archiving in Glacier. The bits outside of AWS then is really how you're going to restore those from a backup or recover an archive to meet a particular requirement of RTO, RPO. So depending on how quickly you want this back, depending upon who needs to authorize what to make this happen, these are the sort of human things that you'd wrap around the DR backup and restore pattern. So let's have a look at how this technically works, or an example typified architecture of pushing backups into AWS. So looking at this diagram, we have a website, mywebsite.com, fronted by our Route 53 DNS servers. When we're running in our colo data center, we have a classic web server, app server, and database server stack. And we have some local storage or disk arrays that attach that database server to handle our application data. And in normal operation, what we're doing is we're taking user requests through that stack, and then shown in yellow is that we're taking periodic database backups and we're pushing them into Amazon S3. Those are being stored in a bucket, shown in blue, and we have a number of those backups going back in time, stored in Amazon. We can also store in S3 images of our servers. So we can create a VM image, if you like, of a database server, an app server, web server, and store them as what we call AMIs, Amazon Machine Images, and also store those in S3. And effectively what we've got here is a frozen state of the servers and the software that's on them, and then we have a series of periodic time snaps of the database that's behind that application. So that gives us the ability, if we need to reconstitute the servers, the web server, the app server, and the database servers, and then to reroute requests to those servers running in AWS using the DNS provider, in this case Route 53. Now the process you put behind that recovery, is the point of the previous slide, is that's a policy and a procedure that you can build around the tooling that we provide you. I mentioned before, once you've sort of managed your backups, that quite often we're looking at data that has some sort of long-term intrinsic value, and that sort of data is the data that we place into a traditional archive. So this might be data you need to keep for regulatory reasons, for example. So traditional tapes are the options here. And recently we introduced a service called Amazon Glacier, which is aimed really at a very low price point at the same durability of S3 for long-term cold storage. So it's a service that behaves in a similar fashion to S3 in that you can create archives and store objects within those archives. But the recovery time for Amazon Glacier is in the period of 3 to 5 hours, whereas S3 is in the period of 10 to 100 milliseconds. So when you push things into Glacier, it's about storing things for a long time and things that you know that you're not going to need to access very regularly, and hence the price point and hence the performance of recovery of that data. So long-term archive, Amazon Glacier is a great solution to replace existing tape archives. I also mentioned before the storage gateway, and if we're talking about backup and archive, the storage gateway is something that is worth considering. So shown here we have two corporate data centers with production systems, Corporate Data Center 1 and Corporate Data Center 2. And we have a storage appliance, which is our storage gateway. So this is an application that you can download and run on your local environment that will be synchronizing data from disks, essentially storage area network that's running in those corporate data centers, into S3 and creating a series of snapshots into S3. And should you need to recover any of the disks that underlie those local production systems, you can use the storage gateway to then reconstitute from a snapshot in S3 the data on a disk and create that as a recovery. You can also take those snapshots that are in S3 and reconstitute them as disks or EBS volumes in the cloud. So you could use Storage Gateway to manage failover or synchronization between two different physical sites, but also as part of a DR strategy that if you were to lose both sites, you can also reconstitute that data in the cloud. Slightly more sophisticated diagram, but along a similar theme, is that this brings together a picture of a storage gateway shown with a yellow wording there, but also something around our relational database server and RMAN. So RMAN is Oracle's backup, and RMAN integrates into Amazon S3. So shown there in our corporate data center, we have an Oracle database server running, and the Oracle RMAN backup is automatically pushing data into S3 for recovery. We also have our AWS storage gateway there, taking snapshots of traditional SAN storage volumes behind an application server that's running there as well. So we're taking a database backup directly into S3, and we're also taking disk backups via the storage gateways into S3. Shown here, I've done the storage gateway over a secure connection, so in this case running across a direct connect. And on the right hand side of the diagram is an Amazon AWS environment. So here we're showing inside a VPC, which is a private networking area. We're showing the recovery of an Oracle database using the RMAN recovery processes. And we're doing data restoration from our snapshots and our AMIs that we have in S3 to reconstitute an application server to recreate the environment that we had in our corporate data center in our VPC. And then our VPC can be accessed by our end users, again over things like VPN, and they can access their internal Oracle application in a DR environment as if they were connecting via a corporate data center. So it doesn't stop at the ability for you to simply manage the, if you like, the byte level object storage of backups, but our services such as RDS support features like Oracle RMAN, so you can take sophisticated database backups and recovery processes from vendors like Oracle and use them out of the box on our services like RDS. So that's backup and restore. The next pattern that we'll discuss this morning is the pilot light pattern. So the pilot light pattern is moving us along that disaster recovery spectrum. So it's about fundamentally building resources around a replicated data set. So the replicated data set and keeping that replicated is, if you like, the pilot light on a gas burner. So you build the AWS resources around that data set and then leave the resources required to run an infrastructure in a stop state, but keep the pilot light on by replicating the core databases that sit behind that infrastructure. So you build resources around a replicated data set, and then you can scale the resources in AWS up in response to a disaster recovery event. So you can start up a pool of resources when the events dictate, and you can match the current production capacity through things like auto-scaling. So you might include these stopped resources in an auto-scaling group, and then when you need to invoke your DR policies, you'll simply issue a command to AWS to say scale the disaster recovery around application X, Y, or Z up from 0 instances to 10, for example. And that's the ability for you then to switch over to systems in AWS with a replicated data set, which essentially drives that name, the pilot light. So a pilot light, looking at it on a diagram basis, we looked at the other ones. We have a website, mywebsite.com, resolving DNS via Route 53 to infrastructure in a colo. And what we're doing here differently is, rather than taking snapshots or backups of a database and moving them across into Amazon S3, is that we're doing database synchronization between a database server running in the physical environment to a database server running in AWS. So whether that be an Oracle database, a MySQL database, an MS SQL, or what have you. And then that database server, using, for example, RDS, we're taking snapshots of that server, storing them in S3, and we're leveraging some of the things of a backup process that I've described before, but wholly within the AWS cloud. What we've done, though, is that we've created, as part of this pilot light architecture, stopped instances or stopped versions of our web server and application servers. So we have them ready, configured, but in a stopped state. And we're not paying for those infrastructure or those instances whilst they're in their state within AWS. Things that are stopped, you don't pay for. When we invoke DR, for example, we would flip our DNS, and then we would start using something like auto-scaling or the Amazon console instances of that web server and app server that have been left in that stopped, frozen state. They come up and start running, they start taking the load, and they're operating upon fresh data because of our synchronized database server. And of course, when your colo data center comes back up, you can reverse the synchronization and then flip your DNS back and then turn the running instances back into a stop state. Okay. Classically, you would take a longer time recovering back than you would on the failover. And if you think about how many different applications you can have in your infrastructure, you might have some that you want to run on a pilot light and some that you want to run on a simple backup and restore process. So it's a mix and match approach to ensuring that the RTO and RPO objectives of any particular application are met with the architecture. So a real customer example of putting these things together, and quite a complex example that I want to step through, is a company called Haven Power. So a utility provider, electricity provider in the south of England, that were looking for a DR site for their European operations for a range of business applications. So this ranged from things that are running on Oracle and SQL Server databases through to virtual desktop environments and the applications that are running on those desktops, their Active Directory, Windows file shares, and so on. And they ended up with a DR architecture that ran entirely within a virtual private cloud, because these were internally facing applications that they were looking to fail over so they can continue things like their call center operations, like continue, for example, their billing processes in the event of some sort of problem. And Smart 421 were the solutions partner, AWS solution provider, that helped Haven Power achieve this vision of their DR and achieve it within AWS. So a logical view of their architecture is that they had two on-premise data centers, Data Center A and Data Center B at the top. And the first layer of their architecture is around the connectivity into their third data center in AWS. Now they did that on a basis of direct connect. So they put physical connections between their Data Center A and Data Center B into the EU region. So again, that's a private bandwidth dedicated line which is physically installed ultimately in a cross connect within their data center A and B. Okay, so connection private to themselves. But to remain fault tolerant of any problems with that physical cable provider, they also had VPN running over the internet. So shown there in the grey cloud, the internet route into their VPN servers inside AWS. So all the connectivity between their physical data centers and AWS ended up in the VPN and proxy server box there, shown just below the yellow circle. And they had dual route connectivity for fault tolerance around this connection. A core part of their infrastructure was the ability for users to log on to services. So if they were in a failed over state, then clearly a key part of their infrastructure for these office workers was the ability to authenticate against the Active Directory. So on our spectrum of architectures, this part of Haven Power's DR strategy was a real-time replication of Active Directory, so running hot. Okay, so their Active Directory servers are always running inside AWS on a particular subnet inside their VPC. So hot portion of their architecture. Another pattern which is useful to impart was the use of Bastion hosts. So we see this commonly within enterprise deployments within AWS, is that you've got a lot of sensitive applications running in AWS, and that the ability for those to be accessed from an operator that might be sat in a physical office that's connected from data center A or B into the resources in AWS is fundamentally turned off. And the only way that you can access AWS resources is by moving through a Bastion host. And in this case, Haven Power actually turn off their Bastion host unless there's a ticket opened in their sort of support systems that means that somebody has to do some work on a particular host or instance within AWS. In which case the Bastion host is turned on, and the administrator is able then to take action on any resource within the cloud VPC deployment from that host that's fully audited and recorded from a change control and access perspective. So a useful pattern that may not be specific to DR, but certainly to VPC deployments around enterprise applications. So they were connected, they had their user database or their Active Directory synchronized, and they had control around the environment from a systems and operations perspective. They then operated Pilot Light for a number of different database applications. So using database replication from Oracle and also Microsoft SQL Server, they were able to then run RDSs inside the disaster recovery environment. And now RDS is our relational database service, and it comes, if you like, pre-packaged with the licenses to run Oracle Standard Edition or Microsoft SQL Server, or you can bring your own licenses for Enterprise Edition Oracle. They ran those databases and they set up the database synchronizations between their physical data centers, so creating that Pilot Light. But they also ran those databases on smaller instance types than they may need. And part of their recovery strategy was not only to launch the applications that had been left in a stopped state around those databases, but also to scale up the size of those database instances at the point of invoking DR. So part of a cost strategy, I guess, in reducing the overall cost of DR is to deploy the minimum amount of resources that are required and leverage the elasticity of the cloud to expand when required, when the load comes at you when you do a failover. Again, they were managing application images, so they were taking golden images and creating AMIs of their applications so that their AMIs were stored in S3 and they could then launch those applications when they failed over. They were also providing remote desktops. So they had a number of different Windows desktop environments running, which ultimately users could remote desktop into. So if they lost a physical facility, they had to move over to maybe a home working or move over to a secondary call center site. That call center could access the remote desktops and all the applications within the DR facility via remote desktop sessions. So they created a capability where they could choose which applications to fail over. They created an environment where they were synchronizing data on a real-time basis. And they created an environment which was essentially lights off until they needed it, apart from the pilot light. And all of this was backed by the durability of the data held in S3. Now, one of the biggest learnings for Haven was understanding when they failed over which bits of the application, under what conditions they could do it. And that drove a lot of thinking around the different mix of architectural models in this DR pattern. So it's entirely possible for them to fail over a single application in a DR plan whilst maintaining all other capability in their on-premise data centers. Or they could move everything over into a secondary failover into AWS. And one of the questions they asked themselves now, because they've experienced the cost savings, they've understood now the architecture differences of using something like AWS versus a physical data center, or indeed the similarity between those two things. They've done a certain amount of learning around the use of cloud services that leads them now to think about production customer-facing systems and how they could be deployed in AWS and leverage the same benefits. So the whole concept of a journey into the cloud and how disaster recovery can be a great starting point, particularly for an enterprise. It allows you to exercise all those different thoughts and feelings and fears and exercise them in a way that actually yields benefits to your organization but isn't in the face of your customer and a transactional system. So where do you go next? So we provide a number of we have a number of technology and services organizations as part of our partner network that can assist you. So whether you're looking to implement some Oracle database backups, we have our Oracle RDS and RMAN support. Whether you're looking for a particular type of storage gateway to manage the backups of particular applications into S3 and the recovery, you can look at some of our technology partners. And then we have people like Smart421 that I've mentioned before, who have taken many companies along this journey, particularly around DR and the enterprise. So have a look at some of our partner and technology partner pages on the website, and you'll find a wealth of information there and different types of products and services that you may find useful to bootstrap a process for you. We have a portion of our website, Amazon.com backup storage. We have a blog that you can learn about new features in this regard, and particularly around things like the evolution of Storage Gateway is one that is receiving quite a lot of updates as we go through the weeks, and you can keep track of those at aws.typepad.com, where you can take an RSS feed and be alerted in your inbox when we've got new particular features or support for particular types of applications. And lastly, we do have white papers on disaster recovery. So some of the content that I've just shown you here is available in a white paper form, where we discuss some of the architectural patterns, we discuss some more detailed products like Storage Gateway and how they can be deployed and used. So in summary, the cloud makes backup and recovery easy. It's very simple for you to take a backup of an application and move that into AWS and then reconstitute that application. And that applies equally for on-premise to cloud deployments or DR setups as it does to cloud. So you can experiment with some of this by opening an AWS account and using the free tier, and try, for example, installing an application on a server, taking a backup of it and reconstituting it. And in 5 minutes you can have enacted your own mini cloud-based disaster recovery process. And you can get started for pennies per month, literally pennies per month. And on the free tier, as I just said, you can have an experiment and a play and it won't cost you anything. So the storage costs in S3 are continually being dropped, as are all costs within AWS. So 19 price drops over the last period of time. And that we continue to focus on price with services like Glacier. So from 1 cent a gigabyte, you can store things indefinitely within Amazon Glacier, compared to the cost of managing tape arrays and cycling data on tapes. The cloud will scale to accommodate all of your data, so there really is no limit to the scale that you can operate here. You could be simply using AWS to back up a small amount of data around a single critical application, or you could be taking an entire copy of archives and storage arrays that you have in your environment and keep adding to AWS and never throw anything away, and it will remain cost effective and will continue to scale to meet your needs. And ultimately, anything you put into AWS is entirely under your control. So we can easily meet the compliance requirements that you may have around the storage of that data, and we can assist you in understanding the security credentials that you might need, or to demonstrate to internal teams when you place a piece of information in AWS, what happens to that data, and how secure is it, and so on. So as I said, you can get started for free. So do try a simple exercise, if you get a chance, of starting an Amazon instance, taking a snapshot of an EBS volume and starting a new instance from that snapshot, because that is essentially the backup and restore pattern in action within a cloud environment.